We're now going to discuss continuous distributions. Now, continuous distributions are those distributions which are fitted to data, which are variables, which are fitted to variables, which are continuous. They can take any conceivable value, and such data like, for instance, temperature, prices, and so on and so forth are all examples of a continuous distribution. So, continuous distribution is distributions, the probability of outcome of a random variable with infinite values and is used to model a continuous random variable. Random variables are uncountable in the continuous case, and the probability of a random variable at one specific point is zero. So continuous distributions are typically described by the probability distribution function. So every distribution, every continuous distribution has a probability density function, which, with the help of which you could generate that distribution, provided you have the values of the parameters. A probability density function, or PDF for short, is a function that is used to calculate the probability that a continuous random variable will be less than or equal to the value it is being calculated. Now you can find out the probability of x being between a and b, or the probability of x being less than b or greater than b. Now this is what a continuous variable looks like. This is what a because it's continuous, you'll take all conceivable values in this range, and this is a continuous distribution, the example of a normal distribution. So in all continuous variable, in all distributions, what we calculate is the expected value. The expected value is nothing but the mean of the distribution. And similarly, we also calculate the variance. Now, important continuous distributions are the normal distribution, the log normal distribution, the gamma distribution, the V-pool distribution, the beta distribution, the Pareto distribution, the logistic distribution, T distribution, and F distribution. So there are many. So we are going to discuss only a few important ones among these, with the most important one is the normal distribution. The normal distribution, undoubtedly the most widely used model of distributions of a random variable, is the normal distribution. All variables are assumed to be normal distribution when we work with them, unless we've tested it and found that it is not normal. So the central limit theorem is also built around the normal distribution, which has the mean, the median, the mode, and also it's also called a Gaussian distribution. Now this is what a normal distribution looks like. Now you get different normal distributions where you find that the mean is the same at 5. The difference you find is in the shape, and the difference in shape is due to the difference in the standard deviation. So a normal distribution has two parameters. One is the mean and the other one is the standard deviation. So as the standard deviation increases from 1 to 9, the distribution gets more flat. So this is the location and this is the shape. So you can see the shape depends on the shape parameter. In this case, it's a standard deviation. So here is another distribution with the mean 0, with mean 15, and standard deviation 1. This is what. So the normal probability density function for the selected values of the parameters mu and 0. So this is called the normal probability density function. This is called the normal probability density function. So you have the variable on the x-axis and the probabilities on the y-axis, and therefore it's called the probability density function. Now the normal distribution has a probability density function which takes a value 1 by 2 pi sigma. 2 pi sigma. Now 2 pi is under root. Sigma is the standard deviation. E raised to the power of 2. Sorry. E raised to the power of 1 by 2 x minus mu the whole square divided by sigma square for all values of x. So this is what generates the probability. What do you mean? The probability density function. So you keep these two are the parameters of the distribution. One is sigma and the other one is mu, which is the mean, and this is standard deviation. And as the variable changes, you get the probabilities for each value of x, and that's called the probability density function. So this is a probability density function. This is a probability density function of the normal distribution. So when I substitute values from this, I get the probability distribution function. So the normal distribution is also called the normal random variable with parameters mu. Now you can see that the mu, the variable ranges from minus infinity to plus infinity. So it takes both negative and positive values. And standard deviation will always be greater than 0. So the expected value of the random variable is the mean, and the variance is the sigma squared. The mean and variance of the normal distribution are derived at the end. So these properties of a normal distribution are very important. So if a variable follows a normal distribution, you have the mean, the mode, and the median coincide. The values are the same. So mean is the average. The median is the middlemost value if the data is arranged in ascending order, and the central value, that is n divided by 2 value, is identified, and that is called the median or the middlemost value, or the mode, which is the most frequently occurring value. So in a normal distribution, the normal distribution is bell-shaped. The mean, the mode, and the median coincide. Now this is very important. Now if you add one standard deviation to the mean and you subtract one standard deviation from the mean and plot it on the figure, it will account for 68% of the area. So if you take two standard deviations around the mean and add it up and subtract 2 standard deviations from the mean and mark it off, that area covers 95% of the area under the normal distribution. The total area under the normal distribution is 1. If you take the mean and add 3 standard deviations and subtract 3 standard deviations, that range will cover 99.7% of the total area. So that covers the bulk of the data. And this property is used a lot in detecting outliers and also to do lots of calculations in management and in statistics. Then that's a normal distribution. So let us get into the data, and let us take an Excel sheet and generate a normal distribution for this data that we had. So the data that we had, we just showed you over there. We'll take a mean 5 and a standard deviation, let's say 2. We will not take the same values. We'll take a mean 5 and a standard deviation 2. So I'll write down the mean over there. Mean is 5. Is 5. You can take any value of this. Nothing hard and fast about it. You can use any value you like. So you take a mean of 5 and you can take a standard deviation of 2. Now I can generate a variable which is going to be normally distributed with this parameter. So to do that, in other words, what you're doing is you're simulating a random variable which follows a normal distribution. So you're simulating a random variable which follows a normal distribution. Okay, so for that, the first thing that I'll do is I have to generate a series of random numbers. So in Excel, the command is just rand, open and close the bracket. So you'll get a random number. These are the random numbers. Now let me generate 100 random numbers. So I need to have the numbers. So I'll generate 1. Just to keep a track, I will say fill. I will say series. I'll select a column and then I'll say the last value should be 100. You can have any number. In this for illustration, I've generated a number. So the advantage is when I click this value and double click it, I'll get 100 random numbers. I'll get 100 random numbers. Okay, so once the random numbers are generated, I need to remove. There's a formula here, as you can see. So I need to remove those formulas. So what I do is I do a copy and then I go to paste special and I will select values and I'll say okay. And these are my random numbers. These are my random numbers. Now Excel has a utility. Now I'm going to generate the variable x, which is going to follow a normal distribution with values very close to this mean and the standard deviation. So the command that I use is equal to norm, because of normal distribution, NORM DIST, and I'll open a bracket, and then it says random number for this x. So this is my x, and then it's asking me the mean. Then I'll select here, and I'll fix it because this should not shift, right? And comma, it's then asking me for the standard deviation. As you can see, standard deviation, and then I'll ask this, and I'll fix that also, and I'll close the bracket, and I'll press enter, and then it's asking me whether you want a cumulative. I say no, so for no I will say 0, and I will get a random number. So it's not a cumulative, it is just a random number. So just to see what that is, you can also say false. I can also say false. So you can please see what I say. I say norms distribution for this value for with the mean 5 and standard deviation 2. I double click it, and now when I did this thing, I remove the formulas from here. So now this is a variable. Now if I take the mean of this variable, I'll just take the mean which I generated. Sorry, the command is average. Sorry, mean. So the command is equal to average this range. So the mean norms, sorry, I made a mistake. This should be norms. So once a random number is generated, I'm now going to generate the variable. So in Excel, the command to generate the variable is equal to NORM INV. Norm inverse, it will give you the number. Now it's asking you, what is the probability? I said, with this probability, with this mean, and with this standard deviation 2, close the bracket, and I've generated a variable. Now I will double click it so that it populates till the bottom for all the 100 observations, and then I get a mean which is very close to this 5, this 4.7. So which means I've generated a data, and then I'll also calculate the standard deviation. I'll also calculate the standard deviation is equal to STDEV, open a bracket. So same range, I will select the data and get a standard deviation, which is not very far from this, right? So I've generated a data. So now I'll treat this as my random variable. And then I will now generate the values. Now I'll fit it into a distribution. So I will take mean. So I'll take the mean. I'll fix it. Sorry. Mean minus 3 standard deviation. So I'll fix it. Okay. Yeah. It should be minus, it's not underscore. Minus 3 standard deviation. Then I will say equal to mean minus 2 standard deviation. Mean minus 1 standard deviation. We go to the positive side. Equal to mean plus 2 standard deviations. Plus mean plus 3 standard deviations. Okay. So now we've developed the class intervals very similar to our distribution. And now let us find out what are the values that are going to be filled over here. Let's recall what we did. So we've got this is the range and equal to frequency. Frequency, right? And that's the data, comma, for the bin range. So asking for bin range, you can see that bin range is my frequencies. I'll close the bracket, control shift, enter. Okay, so now I've got a distribution. Which is it'll be fairly normal. I can fit a distribution. So I'll go to insert, I will go to XY, and I will go to distribution. So you can see like skewed, it's a little skewed distribution. So I really don't know why that has happened. It's a very skewed distribution, which should not have happened. Okay, let me just. I think there's been a mistake, so I should be just going by the strict. I'll go strictly by the maximum minimum criteria. I'll take the maximum of this range. Then I'll take the minimum of this range. I'll fit the distribution the conventional way. That's the minimum. Now I'll form the class interval. I'll take 10 class intervals. So it's maximum minus minimum. So that's a range. I'll make it into 10 class intervals divided by 10. So each class interval will be pointing to. Now I'll make my class intervals. So it is a minimum value plus the class interval. The lower one in the range plus the class interval. Okay, and then I'll just drag it down till I get 10.9. Control D. So it's a few more. Okay, to 10.13. So the 10.1 more will be there. So 10.95 is the highest value. Since the lowest value is not there, I'll remove the highest value and get the distribution from here. So equal to frequency. It's asking me where is the data, frequency of which data, frequency of this data, comma, and then ask me where is the binary range, bin range, bin array. This is the bin array. This is nothing but your class intervals. Close it, control shift, enter.